I already, by convention, making sure my r is non-negative. And tangent theta is equal to y divided by x. Okay? So this is the systems of equations transforming from a polar to right angle and backwards. Okay? You can transform these two systems back and forth with no problem at all. So I don't want to give you any problem to practice how to locate points with respect to two systems. Okay? Probably you have practiced this before. What I do want to do is to practice against the regions. So instead of practicing against the points, let's do it about regions, which is essentially what we're doing here. So the region we're interested in is so-called a polar right angle. So the polar right angle is written down in the following form. So theta is between two angles, and r is between two radius. Okay, so it is called a right angle because similarly as the right angle in the xy plane, we have two numbers for x, two numbers for y. In the polar right angle, we'll also have two numbers for the angle and the two numbers for the radius as well. So that is why it is called a right angle. But in the polar coordinate system, okay? So I see some confusing faces. So next I'm gonna say what they mean. So the angle is between alpha and beta. Essentially, I'm saying this region has to be bounded between two rays. One ray is with respect to alpha angle, the other ray is with respect to beta angle. Are you with me? So if I have the restriction about the angles, this region has to be between these two rays. And the radius between A and B, which is essentially saying the shortest distance between the points in this region and the origin has to be A. The longest distance is B. So this is given by A, and this is given by B. And the region is right here. Okay? Now with me? So the angles are between the rays, and the radius is between two distances. Okay? Now with me? So we're going to practice against couples of examples. So let's see if I have a region R theta, where theta is between 0 and 2 pi. R is between 0 and 2. I want to see where its region is. So theta is between 0 and 2 pi. I have a ray coming here, and I'll have a ray rotating for 360 degrees coming back to the x-axis again. So basically, this restriction does not give you anything. All right? Any point on the whole plane, the angle will be between 0 and 2 pi. Whereas the distance is between 0 and 2, which means I can go as close as to origin as far as to circle with radius 2. So essentially, this is the region right here. Okay? The angle can vary from 0 to 2 pi. The radius can vary from 0 to 2. So this is the region actually, is the disk centered at the origin with radius 2. Okay, with radius 2. Remember, we have dealt with this kind of region before. We have dealt with this kind of region before. I want to ask you, this region, is it an x simple region or y simple region? Is it an x simple region or y simple region? It is both, am I right? It is an x simple region and also y simple region. Again, I want to quickly practice your x simple and y simple skill. If it is a y simple region, I need two numbers for x. So the two numbers are x is bounded between -2 and 2. I have two functions, the lower function and the upper function. The lower function and the upper function are coming from the radius 2 circle, x squared plus y squared is equal to 2. Right? So I need to solve for y right here because I want to have a lower function and upper function. The lower function is minus, q squared minus 4 minus x squared. All right? If you solve for y is equal to 4 divided by x squared. Y squared is equal to 4 minus x squared. If I solve for y, the minus square root is going to give me the lower curve. The positive square root is going to give me upper curve. And it is bounded between the lower and the upper. Okay? So y is between minus square root of 4 minus x squared and plus 4 minus x squared. Okay? Questions? Okay? This is a y simple region. X is bounded by two numbers. Y is bounded by a lower function and an upper function. I can also identify this as an x simple region, where my y is bounded by -2 and 2. And this piece of the arc is going to be the curve to the left. This piece of the curve is going to be the curve to the right. So this is the left, this is the right. So y is between -2 and 2. X is between the square root of 4 minus y squared minus and plus 4 minus y squared. This one defines the left curve. This one defines the right curve. Okay? Okay. Now, not only I can transform a region between x and y simple regions, I can indeed transform between polar x and y simple regions. So a region can be identified by different systems, and you gain different advantages in identifying in different systems. Okay? So I want to quickly go beyond and practice a couple of more identification problems. So let's see, I have a region R in the polar rectangle system such that R is between 1 and 2. Theta is between 0 and 2 pi. Okay? So theta is between 0 and 2 pi. Again, I don't have any restriction coming from the angle. Right? It's going to be the ray of 0 and a ray of 2 pi. So they coincide at a positive direction of x-axis. So they don't give you any restriction. Where my distance is between 1 and 2. So the shortest distance is going to be given by a circle with radius 1, and longest distance is going to be a circle with a radius 2. The points have to be lining in between. All right? The points have to be lining in between. This is the region right here. This region is what you call in English analysis, right? What do you call it in English? Analysis, torus. Torus?
Washer. Torus is the.
It's a washer,
Okay, whatever.
Donut.
So, donut is still solid. But anyway,
That's sprinkles.
I wanted to still ask you the question. If I want to identify this as an x simple, y simple region, it's going to be super complex. Right? It's going to be super complex. You have to divide it into different pieces and then identify which one is upper, which one is lower. All right? For instance, if I'm looking at the upper half, this curve is the lower function, this curve is the upper function. But if I'm looking at the lower half, the rows are switched. This function becomes the upper, this function becomes the lower. So identifying this region as x simple, y simple region, you can still do that, but it's going to be more complex. But indeed, in terms of the polar coordinate system, it's super easy. All right? In the polar coordinate system, it's so easy. That's why in polar coordinate system, it deals very nicely in these type of regions and in this type of regions. If it looks like a disk or an analysis or torus, whatever you want to call it, or a piece of torus, it's going to be very nicely applicable. So I want to quickly give you one more example so we can do some actual evaluation. So this region is slightly different with this guy. I have the same restriction about the radius, but I have also got a restriction, a real restriction on my angle. So the angle is between minus pi over 2 to pi over 2. So the rate of the angle coming from this two is going to be from a negative direction of y-axis up to positive direction of axis. All right? That with me? So it's going to be go this direction. So from minus pi half to pi half, so this region is going to be only the right half of the analysis right here. Okay? So now you should feel very comfortable in giving different directions, given different restrictions about r and theta, and locate where this is. Okay? Locate where it is. So given the restriction of radius, restriction of angle, you'll be able to find where this region is. Okay? So next, I want to give you the formula about the double integral. Still, we haven't escaped the double integral yet. Still, we're looking at this simple formula. Now, if my region can be regarded as a polar rectangle, then this double integral is going to be equal to from alpha to beta, from a to b, f r theta, then dr d theta, with one extra factor r here. Okay, this is the biggest difference between the rectangle system and the polar system. In the polar system, if it is a rectangle, I still have these two iterated integrals. I need to change the function from xy to r and theta. And intervening variables become r and theta. But there is this one additional factor coming in. There's one additional factor r coming in. So do not forget about this r for all time. Okay, so you have to keep this r in all times if you use polar coordinate system. Even in triple integral, we go beyond into cylindrical coordinate system and spherical coordinate system. You're going to get the factors coming out of it. I will explain why you have an additional factor coming here. Okay, so you might ask, why am I getting an additional factor? It will be explained in the future. But right now, let's remember this formula and practice against a couple of examples. Okay, so usually when you are looking at a problem involving double integrals, they will not give you a double integral already written in the iterated form, so you can do the evaluation first. Okay, the very beginning. Usually they will give you a double integral. They will give you some information about the region. You need to transform this information into either x simple or y simple or polar coordinates. Okay, you need to transform this information into the required formula. Okay, so this region is bounded between x squared plus y squared is equal to 25, which is a circle, and it is restricted in the first coordinate. Okay, so you can easily identify right here. Okay, so this is 0, 5, and this is going to be the region right here. Okay, and then I need to rewrite this one in polar coordinate system. In polar coordinate system, this is a region which is exactly a polar rectangle. R is between 0 and 5. Angle is between 0 and pi half. All right? So this is nothing but R between 0 and 5, theta between pi half and 0. So I can easily write down this as 0 to pi half, from 0 to 5. And then I need to transform everything into r and theta. Right? But we have done that before. So x squared plus y squared is equal to r squared, all right? So you have x squared plus y squared is equal to r squared. So this is nothing but 36 minus r squared. But I have one additional factor, r here, dr d theta. And then you can evaluate. Okay? You can easily find the antiderivative of this whole function right here. Okay? You can find the antiderivative and then you can evaluate the following. So the answer, which I have done before, is 6 minus square root of 11 multiplied by pi half. Okay? Okay? Okay, next I want to give you questions. So after we have introduced so many different types of regions, evaluating a double integral, the most important step is to decide which system you want to use, which type you want to identify your region, whether you want to use y simple, x simple, or a polar rectangle. Usually they're not going to give you a rectangle. That's too easy. So you have to decide which one you want to go. Okay? Usually you can choose different types to do the same problem. For instance, you can use both x simple and y simple and a polar coordinate system. But one of them is going to be pretty friendly to work with. And big hint you want to use polar coordinate system is you see these kind of terms. If your integrating function has x squared plus y squared, do not hesitate to use polar coordinate system. In these guys, if it is appearing in the square root or in some other places, finding the antiderivative is going to be a pain. Pretty hard to find the antiderivative. But after you transform x squared plus y squared is equal to r squared, usually the questions is much easier. Okay? For instance, I want to find the area of a disk with radius r. So this is my problem. This is my problem. Okay? So the very first step, I can easily write down the formula required here. I needed to do a double integral with restrict to a constant function 1, right? Which is what we just discussed. So it becomes